Welcome to Physics Students channel. Today we are going to discuss some of the problems based on the topic waves and oscillations. Before going to the problems, we have to know some of the formulas which are mainly used to solve the problems, such as the formula for beat frequency and the equation of a progressive wave. There are 6 types of equations which is related to the equation of a progressive wave. These formulas are very useful to solve the problems. Let's go through the problems. The first problem was two tuning forks P and Q produce 4 beats per second when sounded together. The frequency of P is 480 Hz. When Q is loaded with a wax, the beats stop. Calculate the frequency of Q. Here in the question, we come to know that there are two tuning forks named as P and Q. They produces 4 beats per second when they are sounded together. At that time, the frequency of tuning fork P is 480 Hz. But we don't know the original frequency of Q. But after that, they added or they loaded a wax on the tuning fork Q. At that time, the beats heard per second stops. Hence, we have to find out the frequency of Q. First of all, we have to note down the given values. The given values, Fp is nothing but frequency of tuning fork P. Fp is equals to 480 Hz. Beat frequency Fb is equals to 4. By the question we came to know that after loading Q with wax, the beats stop. Then we know the formula for beat frequency. Fb is equals to Fp difference Fq. Now we have to calculate the frequency of Q. Hence Fq is equals to Fp difference Fb. Then Fq is equals to 480 plus or minus 4, where Fp frequency is 480 Hz and beat frequency is 4. Then Fq is equals to 484 or 476 Hz. Here there are two frequencies of Q. In that two, we have to select a correct one. So in the question we come to know, after loading Q with wax, the beats stop, which means after loading, the frequency of tuning fork decreases. Hence no beats are heard. So here we can observe the frequency 476 Hz, that if the frequency of Q originally is 476 Hz, after loading on it, its frequency decreases, which means after loading the frequency is less than the 476 Hz. Then the beats heard per second increases. So that we have to know for 484 Hz. At that time, the frequency decreases when loading on Q with wax. Then the frequency of P tuning fork and frequency of Q tuning fork becomes equal, and then the beat frequency between P and Q tuning fork becomes 0. Then the original frequency of tuning fork Q is 484 Hz. Then next second problem. A tuning fork of unknown frequency produces 5 beats per second with a fork of frequency 512 Hz and 7 beats with a fork of frequency 514 Hz. Calculate the frequency of the fork. Here a tuning fork which has unknown frequency, but it produces 5 beats per second when sounded with a frequency of 512 Hz, and the unknown frequency tuning fork produces 7 beats per second with a fork of frequency 514 Hz. Here totally there are 3 tuning forks. One is unknown and another two are 512 Hz and 514 Hz. When unknown frequency is sounded together with the fork of frequency 512 Hz, it produces 5 beats per second. And again, unknown frequency sounded with a tuning fork of frequency 514 Hz, it produces 7 beats per second. Now we have to calculate the unknown frequency of a tuning fork. So first of all, we have to note down the given values. Let N1 be the unknown frequency. We have to consider that N1 be the unknown frequency of a note. In first case, we come to know that when unknown frequency is sounded with a tuning fork of frequency 512 Hz, it produces 5 beats per second. By using the formula of beat frequency, we get N1 is equals to 512 plus or minus 5, where 512 is the frequency of a tuning fork and 5 is a beat frequency. By adding and subtracting, we get N1 is equals to 507 or 517 Hz in first case. Similarly, in second case, N2 is equals to 514 plus or minus 7, where 514 is a frequency of a tuning fork and 7 is a beat frequency when they are sounded with a unknown frequency tuning fork. By adding and subtracting, we get N2 is equals to 507 or 521 Hz. We have to calculate unknown frequency so that in both cases the unknown frequency of a tuning fork must be same. Hence, the unknown frequency is 507 Hz, which is common at first and second case. So, the answer of unknown frequency is 507 Hz. Then the third question is, a tuning fork P of frequency 256 Hz produces 6 beats per second with a tuning fork Q of unknown frequency. When Q is filled, 6 beats per second are heard again. Calculate the frequency Q before and after filling. Here there are two tuning forks P and Q. The frequency of P is 256 Hz. We don't know the frequency of Q tuning fork. But when P and Q are sounded together, they produces 6 beats per second. And again, on filling to the tuning fork Q, again 6 beats per second are heard. Hence, we have to find out the frequency of Q before and after filling. So, first of all, we have to note down the given values. FP is frequency of P tuning fork, which is 256 Hz. Beats heard per second is 6 before filling and after filling. So, first we have to go through the process before filling. FQ is equals to 256 plus or minus 6. We have to find out the frequency of Q, where 256 is the frequency of P and 6 is beats heard per second or beat frequency. By adding and subtracting, we get FQ is equals to 250 or 262. 256 plus 6 is 262, 256 minus 6 is 250. Here we come to know that the frequency of tuning fork Q have two frequencies. One is 250 and 262 Hz. Now we have to note down the frequency. We have to note down the frequency of before filling. Then we have to note that after filling the fork, the frequency of fork increases, which means the frequency of Q is 250 Hz before filling and the frequency of Q is 262 Hz after filling. So the answer of unknown frequency of Q before filling is 250 Hz and after filling is 262 Hz. Then fourth problem, a tuning fork A gives 6 beats per second with another tuning fork B of frequency 341 Hz. When A is filled, the beats occur at shorter intervals. What is its original frequency? Here there are two forks, A and B. A is unknown frequency tuning fork and the frequency of B is 341 Hz. When A and B are sounded together, they produce a 6 beats per second where beat frequency is 6. When A is filled, the beats occur at shorter intervals, which means the beat frequency decreases. So we have to find out the original frequency of tuning fork A. First of all, we have to note down the given values. So the given values are FB, where the frequency of B is 341 Hz, beat frequency is 6. Now we have to find out the frequency of A tuning fork. By using beat frequency formula, frequency of A is equals to 341 plus or minus 6, which is equals to 347 or 335 Hz. We know that by previous problem, when a tuning fork is filled with wax, its frequency increases. So that by this we come to know that after filling the wax on A, it produces more beats per second. Hence, the frequency of A is the 347 Hz. Then, the fifth problem was the equation of progressive wave is given by y is equals to 5 sine into 10 pi t minus 0.1 pi x, where x and y are in meter and t is in seconds. Calculate its amplitude, frequency, time period and velocity of the wave. So here the question is that they given an equation of a progressive wave, that is y is equals to 5 sine 10 pi t minus 0.1 pi x. So this is similar to the equation y is equals to a sine 2 pi t by t minus 2 pi x by lambda. So now we have to find out the amplitude, frequency, time period and velocity of the wave. By comparing given equation and compared equation, we come to know the amplitude, frequency, time period and velocity of the wave. Then by comparing the two equations, we come to know that A is equals to 5 and T is equals to 1 by f. So first of all we have to know the frequency. 2 pi by t is equals to 10 pi. We know that f and t are inversely proportional to each other and time period is equals to reciprocal of frequency and frequency is the reciprocal of time period. So by using that formula, 2 pi f is equals to 10 pi. Pi gets cancelled, 2 ones are 2 5s. So f is equals to 5 Hz. By using the formula between the frequency and time period is given by t is equals to 1 by f. By substituting the value of f in equation t is equals to 1 by f, we get t is equals to 1 by 5, where 1 by 5 is equals to 0.2. Hence, the time period of a wave is 0.2 seconds. And we also know that v is equals to a omega, where omega is equals to 2 pi f. F is frequency, so v is equal to, substitute omega is equals to 2 pi f, v is equals to a into 2 pi f. We know the value of a, that is 5. 2 into pi value is 3.142 and the frequency value is 5. So the total answer of velocity of wave is 157.1 meter per second. Hence, the amplitude of a wave is 5 meter, frequency is 5 Hz, time period is 0.2 second and velocity of the wave is 157.1 meter per second. Then the sixth question was, when a simple harmonic wave is propagated through a medium, the displacement of a particle in centimeter at any instant of time is given by y is equals to 10 sine 2 pi by 100 into 36,000 t minus 20. Here we have to calculate the wavelength and frequency of a vibrating particle. Here y is equals to 10 sine 2 pi by 100 into 36,000 t minus 20 is an equation of a progressive wave which is similar to y is equals to a sin 2 pi by lambda Vt minus x. So by this we come to know, by comparing those two equations, lambda is equals to 100 and V is equals to 36,000 T and X is 20. But in this question we have to calculate only the wavelength and frequency of a vibrating particle. By the comparing we get the wavelength lambda is equals to 100. We know that V is equals to F lambda, where F is frequency and lambda is wavelength, V is the velocity. So we have to calculate the frequency of the wave, that is F is equals to V by lambda. We know that V is equals to 36,000 and lambda is 100. F is equals to 36,000 divided by 100 is 360 Hertz. Therefore, the wavelength of a particle is 100 meter and frequency of a vibrating particle is 360 Hertz, which is traveling in a medium. Then 7th question. A tuning fork A of frequency 288 Hz produces 4 beats per second when sounded together with a tuning fork B of unknown frequency. When A fork is loaded with wax, no beats are heard. Calculate the unknown frequency of B. So in this question we have two tuning forks A and B. We know the value of frequency of A, that is 288 Hz, and we don't know the frequency of tuning fork B. When A and B are sounded together, 4 beats are heard per second. But after loading a wax on A tuning fork and then again sounded together, no beats are heard. Now we have to find out the frequency of B. So that we have to note down the given values. So the given values are FA, which is frequency of tuning fork A is 288 Hz and beat frequency is 4. We have to find out the frequency of B. By the formula beat frequency FB is equals to FA difference FB. We know the value of frequency of A tuning fork and beat frequency. By substituting it, we can find out the frequency of B. So FB is equals to 288 plus or minus 4. By adding and subtracting we get 284 or 292 Hz. So here there are two frequencies of B, but we have to check which is correct one. We know that on loading a wax on the tuning fork, its frequency decreases. Hence, the frequency of B is. End question. The ratio of frequencies of two forks is 64 by 64 is to 63. They produces 2 beats per second when sounded together. Calculate their frequencies. Here there are two forks in which the frequencies of forks are given in the ratio 64 and is to 63. And when they are sounded together, they produces 2 beats per second. Now we have to calculate the frequencies of two tuning forks. To solve this problem, there are two methods. The first method was F1 by F2 is equals to 64 by 63 is given by in the question. We know the beat frequency FB is equals to 2, that is F1 difference F2 is equals to 2. So by F1 by F2 is equals to 64 by 63, we can replace or change this in terms of F1 by F1 is equals to 64 into F2 by 63, where F2 comes to RHS, it becomes multiplication. So, substituting F1 value in beat frequency formula F1 difference F2 is equals to 2, we get 64 into F2 by 63 difference F2 is equals to 2. 64 F2 minus 63 F2 by 63 is equals to 2, where the LCM is 63. Then 64 F2 minus 63 F2 is F2. F2 by 63 is equals to 2. 63 goes to RHS and becomes multiplication with 2. Then F2 is 126 Hz. So here we come to know the frequency of second tuning fork F2 126 Hz. By using the value of F2 we can find out the frequency of first tuning fork. So by the formula F1 is equal to 64 into F2 divided by 63. F1 is equals to 64 into 126 divided by 63. 63 ones are 63 twos are get cancelled. So 64 into 2 is 128 Hz. Therefore, the frequencies of tuning fork first and second are 128 Hz and 126 Hz respectively. Then another method is to solve this problem was by using beat frequency formula or by using the ratio or by subtracting -1 on both sides. F1 by F2 is equals to 64 by 63. F1 minus F2, which means the by subtracting -1 on both sides we get F1 minus F2 by F2 is equals to 64 minus 63 by 63. We know that F1 minus F2 is equals to 2. By substituting the value of F1 minus F2 in the equation we get 2 by F2 is equals to 1 by 63, where 64 minus 63 is 1. So F2 is equals to 63 into 2, we get 126 Hz is equals to 50 F2, where the frequency of second tuning fork is 126 Hz. Substituting the value of F2 in the equation F1, we get F1 is equals to 128 Hz. So then the frequency of first and second tuning forks are 128 Hz and 126 Hz respectively. And the ninth question, the velocity of sound in air at NTP is 380 meter per second. At what temperature will the velocity be 480 meter per second? Here they given at normal temperature and pressure, velocity of sound in air is 380 meter per second. We have to calculate the temperature at which the velocity is 480 meter per second. We know the relationship between V and T, that is V is equals to square root of T. So first we have to note down the given values. V1 is 380 meter per second, V2 is 418 meter per second. At normal temperature and pressure, the temperature is 20 degrees Celsius, where it is in degree Celsius. By converting it into degree Kelvin, T1 is equals to 293.15 Kelvin. So now we have to calculate T2. We know that V is equals to square root of T. Substituting these values, we can get the value of T2. So V1 by V2 is equals to square root of T1 by T2. Squaring on both sides, we get V1 by V2 whole square is equals to T1 by T2. T2 is equals to V2 by V1 whole square into T1. We know the value of V2 418 and V1 is 330. By substituting in the equation, we get T2 is equals to 418 by 330 whole square into 293.15, where 293.15 is the temperature 1, which is the first temperature. By simplification, we get T2 is equals to 470.31 Kelvin. Here the temperature is in degree Kelvin, but in question they asked in degree Celsius, so we have to convert it into degree Celsius by subtracting 273.15. So we get 470.31 minus 273.15, we get 197.16 degrees Celsius, where the temperature 197.16 degrees Celsius. At that time the velocity becomes 418 meter per second. Then the 10th question, 48 tuning forks are arranged in order of increasing frequencies such that each gives 5 beats per second. When sounded with the previous one, the last fork is the octave of the first. Calculate the frequency of the first, 15th and the last tuning fork. So totally there are 48 tuning forks which are arranged in order that the beat frequency between the first and second tuning fork is 5 and then second and third tuning fork is 5. In each sounding, the beat frequency is 5 beats per second. Here they given that when sounded with the previous one, the last fork is the octave of the first, which means the second frequency must be the twice that of first. Hence, we have to calculate the frequency of first, 15th and the last tuning fork. Here we observed octave is nothing but a frequency twice that of other. Let us consider n be the frequency of the first tuning fork and then 2n will be the frequency of the last, which is octave of the first tuning fork. So these 48 tuning forks are arranged in arithmetic series with a common difference 5. Hence, the series can be written as n is the frequency of a first tuning fork, n plus 5 is the frequency of second tuning fork. Similarly, it can be written as n plus 5, n plus 2 into 5 up to n plus 47 into 5, where n plus 47 into 5 is a 48th frequency of a tuning fork, which is a last frequency. Then, by substituting 2n minus n is equals to 47 into 5, we consider that last frequency must be equals to 2n. Hence, it is substituted in the equation and then we come to know that n is equals to 235 Hz. Hence, the frequency of first tuning fork is 235 Hz. Now we have to calculate the last tuning fork, which is 2n. Substituting the value of n in the equation, we get 2 into n, where 2 into 235 is equals to 470 Hz. Hence, the frequency of the last tuning fork is 470 Hz. And now we have to calculate the frequency of 15th tuning fork, where it can be written as n plus 14 into 5, which is equals to 235 plus 70, where the value of n is 235, 14 into 5, 70. By adding those, we get 305 Hz, which is the frequency of the 15th tuning fork. These are the some of the problems based on the waves and oscillations which are useful for the exams. Thank you for watching.